The work I'm presenting here is a test of a magnetohydrodynamic or MHD model to predict magnetospheric substorms. A substorm occurs when solar wind energy arriving at the Earth is built up within the Earth's magnetotail and then is released explosively toward the Earth. And this process can impact infrastructure both on the ground, such as power grids, and also in the space environment. The MHD model that I'm using is the Space Weather Modeling Framework. It's used by many researchers and also operationally by Noah Swipsey. And this and other MHD models have been used for many years to study substorms on a research basis, but no MHD model has been demonstrated to consistently and reliably reproduce observed substorms. So in this work, I set out to test the ability of SWMF to predict substorms. My approach was to simulate a 1-month period, January 2005, and look for substorms in the model output, comparing those two observations. And this last step was complicated by the fact that the research community disagrees significantly about the correct procedure to identify substorms. And this is in part due to the fact that there's lots of different observational data sets that people use to identify substorms. And all of them have limitations. They can falsely identify substorms and they can miss real substorms. And so my approach was to develop a new technique that merges lists of substorms that come from different sources together, producing a new consensus list that avoids some of the limitations of the individual data sets that were fed into it. And I used the same technique to identify substorms in the model output, then calculated a Heidke skill score for the entire month based on 30-minute bins, and I found that my Heidke skill scores were significantly greater than 0. That is, the model was predicting a statistically significant fraction of the substorms, and over and above what would be expected by random chance. And so in conclusion, I've developed a new technique for predicting substorms that utilizes multiple data sets. And using this technique, I demonstrated that substorm prediction with an MHD model is possible.